Hello children, welcome to your chemistry online class. Last class we have seen different types of crystal structures. In today's class we are going to detailedly discuss about crystal structures. Crystal structures can be identified by the method crystallography. And we know crystals have indefinite shape and the units of a crystal is repeating. There are repetitive units in a crystal. So these repetitive units are known as unit cell, and the arrangement of unit cell in the three-dimensional, that is XYZ axis, is known as space lattice. We'll detail see what is space lattice and unit cell and types of unit cell in today's class. So the crystal lattice is three-dimensional structural arrangements of atoms, ions or molecules. It may be atoms or ions or molecules. In a crystal, it may contain atoms, ions and molecules. It is a three-dimensional arrangement. If you see this picture, you can see that a three-dimensional arrangement of atoms in a structure. This is a geometrical arrangement of atoms, ions or molecules in a crystalline solid or in space. So these points, it may be atom, ion or molecule. What are the characteristics of crystal lattice? So in a crystal lattice, each atom, molecule or ions represented by a single point. These points are called lattice point or lattice site. This joined together give a crystal lattice. And we join this, we'll get a three-dimensional structure. This arrangement is known as Brevis lattices. We'll see this. This is a crystal point. It's a point, lattice point. If we joined this one, we'll get a crystal lattice. There are different types of crystal lattices that we can call it as Brevis lattices. Three-dimensional arrangement of crystal lattice. So we'll see what is unit cell. Unit cell is the smallest part of a crystal. We know in our body the smallest part is cell. Entire body, the smallest part is cell. Similar to this, the smallest part of a crystal is cell, that is unit cell. It is the simplest repeating unit in a crystal structure. Entire lattice is made up of the repetition of unit cell in different direction. We'll see what is an unit cell. If you observe this structure, you can see a small cube. This is a unit cell. And if you observe this one, there are so many unit cell. These unit cell are repeating. These are repeating arrangement. So the unit cell repeats itself and produce a crystal lattice. Similar to this, one cube is here, and you can, if you observe, another cube will be here. So there are so many cubes, so many unit cell. The unit cell not only in the form of cubes, there are another types of unit cell. We'll see how we can classify unit cell. So unit cells are the repetitive units. So based on these parameters, we can further classify unit cell. What are the parameters? We know if you take a rectangle, the parameters are there. That is sides, Similar to this, unit cell is a cube. Not only cube, unit cell is a structure. So if it is a structure, it should have some definite parameters. We'll see that. The parameters are three edges. Here you can see the edges. This A, C, B. Along the x-axis, the edge is A. Along the y-axis, the edge is B. Along the z-axis, the edge is C. These are the three edges of unit cell. This is a small view of unit cell. And the angle between the edges are also considered as parameters. That is, between A and C, beta is there. Between A and B, gamma is there. Between B and C, alpha is there. These are the angle between unit cell. Based on this edges and angles, we can further classify unit cell. The major classification you can see, unit cell are classified as primitive unit cell, centered unit cell. We'll see what is primitive and centered. Centered unit cell further classified as body centered, face centered and end centered. These are not the exact types. There are so many other types that we'll discuss. So what is primitive unit cell? If in this image you can observe that the atoms, ions or molecules which are arranged or which are only in these particles occupy only the corners. If the particles occupy only the corners, we can call it as primitive unit cell. For example, cubic unit cell. Symbol cubic. So this is primitive unit cell. So only the corners. So we'll see what is centered unit cell. So what will be centered? Not only the corners, in the center or edge or face, there will be atoms. So centered unit cell, when the constant particles occupy other position rather than corners, other position other than corners are known as centered unit cell. Three types are there. Body centered, this is symbol cubic. To the symbol cubic, we can see only in the corners. But in the center, if you see here, which is in the different color is given, the blue color is given. If it is in the center, one more particle is there, then we can call it as body centered. We know if you take a cube, it has face, edge, center, corner, etc. So, in the face, how many faces are cubes having? 6 faces are there. If the atoms are also in the face, then we can call it as face centered. 8 corners and 6 faces. Then another type is end-centered. End-centered means when the constant particle present at the center of two opposite faces, it is known as end-centered. You can see here. Here you can see here in the end, in the middle of two atoms, you can see one more. That is opposite to, in opposite phases, it will be there. That is end-centered. These are the major types of unit cell. And other classification also there. We have said that there are six parameters, that are edges and angles between that. Based on these edges and the length of the edges, angles of the edges, the length and angles of the edges, we can further classify it as 7. In the 7 also further classifications are there. That is, we have seen that cubic, in cubic, symbol cubic is there, face centered cubic is there, base centered cubic is there. Similar to this, though, for all this there are different types also there, but for you only this much will be there. So based on this edges and angles, we can further classify it as cubic. In cubic, if this A, B, C, that is our edges. If the edges are equal with this angles are 90 degree, then we can call it as cubic. Tetragonal. We know the shape tetragonal. It is simple like max. Tetragonal we know two edges are equal and one edge is not equal. A equal to B not equal to C. Then angles are equal to 90 degree. Then it is tetragonal. Orthorhombic. Three edges are not equal but angles are equal. Then it is orthorhombic. Monoclinic. Similar to this, you can see monoclinic. Three are not equal but alpha is equal to gamma, that is alpha. Angle between B and C edges and A and B are equal, but then that also in 90 degree, but it is not equal to beta. Then it is monoclinic. Hexagonal also you can see. Rhombohedral also you can see. Triclinic. Triclinic is nothing is similar. Everything will be different. So these are the types of unit cells. Brevis lattices. So this arrangement is known as Brevis lattices. Then another important thing is coordination number. You may know what is coordination number. So the coordination number of any constant particles in a given unit cell is the number of particles touching that particle. For example, if you see here, each particles are touching each other. If we take a structure, if this is a single unit cell, we have seen a lattice. In this lattice, if you see here, each unit cell are touching each other. This one single unit cell, it is touching with other unit cell. So every unit cell are touching each other. So how much they are touching each other, that is their coordination number. And how to calculate the coordination number for per unit cell. So for that there are several things are there. That is, an atom at the corner is shared by 8 unit cells. If you observe an atom in the corner, it will touch with or it will attach with 8 other unit cells. So, if for a cube, there are 8 points are there, lattice points. So, these all 8 lattice points will attach with other unit cells. So, we can see, so an atom at the corner, for the example, this atom at the corner attached with other shared by 8 unit cell. So contribution of 1 is 1 into 1 by 8. And if it is in the phase, we know in the phase it is sharing with two unit cell. If it is in the phase, two phase will attach. So each phase is shared with 2 unit cell, its contribution is 1 by 2. So 1 into 1 by 2. If it is center, it won't share with anything, so its contribution is 1. If it is edge, the 4, its contribution is with 4 edges, so 1 by 4. So how to calculate the contribution body center? For example, you see with body center. So in body center, we know 8 atoms in the corner. So each atom, one atom will give 1 by 8. So 1 by 8 into 8. So we'll get 1 atom. The question will be how many atoms are there in the base centered cubic cell. Then only 1 atom in the center, its contribution is 1. So total number of atoms is, we have to total it. 1 plus 1 is equal to 2 atoms. Similar this way we can calculate with cubic and another's.